Welcome to the ftir.fun Infrared Learning Series. This episode, Ep13 Introduction to Sampling Techniques, Transmission Method, we brew pellet, liquid cell, then film, then close with a checklist. Next, IU. A good spectrum depends 70% on sample preparation. An old saying in the lab goes, the instrument determines the lower limit, but sample preparation determines the upper limit. No matter how advanced the ftir, if the sample is poorly prepared, the resulting spectrum will be garbage, baseline, tilt, severe scattering, absorbs saturation, water peaks covering target peaks. The root cause of these problems is almost never the instrument, but sampling. Next, Devisif principles of transmission. 1.1 What is transmission measurement? Transmission measurement is the most direct infrared sampling method. Upshing the infrared beam passes through the sample. Then the detector measures the intensity after transmission. The sample absorbs light at specific frequencies, so the transmitted light is weakened at corresponding frequencies, forming absorption peaks. Next, Pellet method, the gold standard for solid samples. The Pellet method is a classic standard method for infrared identification of solid organic compounds, widely used since the 1950s. Its core idea is mix a small amount of sample with high purity powder, press into a transparent pellet under high pressure, and place it in the light path for measurement. Next, Just cell method, standard method for liquid samples. 3.1 Measurement principle for liquid samples. When measuring liquid samples, the path length is determined by the gap between two windows. Key considerations: aqueous liquids, high molecular density, path length of 10-100 micrometers, capillary film or short path length, cell dilute solutions, path length of 0.12 millimeters, medium long path length cell, aqueous solutions. Strong water absorption requires path length 30 micrometers. Next, film method, a powerful tool for polymer measurement. The film method, cast film, melt film, is specifically for polymer samples. The principle is to prepare a uniform film with a thickness of 1050 micrometers and measure directly in transmission. 4.2 Solution casting method. Next, the gas cell, a dedicated tool for gas samples. 5.1 Specifics of gas measurement. Gas samples have much lower molecular density than liquids, solids, requiring long path lengths to achieve sufficient absorption. Next, comprehensive comparison and selection guide for transmission methods. 6.1 Comparison of sample preparation methods. Table 6 Comprehensive comparison of sample preparation methods for transmission mode. Next, future of transmission, coexistence with artery. 7.1 Current status of transmission. Although artery has become the mainstream for routine analysis, detailed in Ep13, transmission remains irreplaceable as the standard method in the following areas. Next, we receive a highly hygroscopic solid sample. After pellet preparation, a broad peak appears at 3,400 centimeters. Finally, the drill actualists. Make sure you can recall each item. Transmission principle. Light passes through sample, transmitted light detected. Path length 1050 micrometers. Path length control. Pure liquid 10-100 micrometers. Dilute solution 0.12 millimeters. SCN. Scattering control. Particle size 2 micrometers to avoid scattering. Pellet method. Classic solid method. Sample. equals 101. Carbon. 17 tons pressure. Advantages. Completely transparent in mid-ear range. No interference peaks. Limitations. Hygroscopic. Water peaks at 3,400, 1,640 centimeters. Not suitable for polymorph analysis. Liquid cell types. Demountable, easy to clean. Fixed quantity. Capillary film. Quick gen. Window material selection. Dry use. brew. Aqueous use. base ERs. Solvent compensation. Double beam subtraction or background method. Film method. Testing. polymer, Putrescine, thermoplastic polymer, gas cell, short cell FO 10 centimeters, high concentration, white Harriet cell, 100 Ms trace, status of transmission, still irreplaceable, Rhyacopia quantification, gas, libraries, teaching, that covers the required sample for this episode. Practice with real spectra on ftir.fun, and continue with the next lesson.